good afternoon, ladies and gentlemen. It's an absolute pleasure to be able to present to you today. My name is Ruaan. I'm from sunny Cape Town, South Africa. I'm a project manager at Homebrew Films, and what we mainly do is we create wildlife documentaries. But I did study zoology at the University of the Free State. I did my master's in fish parasitology, so I know a little bit about water. And we've done a few films about water as well, and it's going to be wonderful to speak to my main audience to this afternoon, the students at the University of Botswana. It's absolutely wonderful to have you all in, and thank you very much for everyone else who's joining in. My colleagues and friends, it's absolutely wonderful. Can I get away from the students there? Are you all awake and alive? And there we go, one or two of you are, but that's wonderful. So I'm going to start off with, I told everyone, but this is a little anecdote. This photo was taken of me in Botswana almost 12 years ago when I was doing research with Professor Liesel van As at the University of the Free State in the Okavango Delta. So the usefulness of water. I'm going to start off with a little quote that I love. Far out in the uncharted backwaters of an unfashionable end of the western spiral arm of the galaxy lies a small, unregarded yellow sun. And orbiting at roughly 98 million miles is an utterly insignificant little blue-green planet. Now, this is from The Ultimate Hitchhiker's Guide to the Galaxy by Douglas Adams. If you have not read it, please do so. But today I'm not going to focus on the utterly insignificance of the little blue planet. I'm going to concentrate on the blue of our little green planet. Let's hope it's going to be wonderful. So water everywhere, and it's absolutely bloody remarkable. If you don't know about water, this is to the students, this is really, it's one of the only substances on Earth whose chemical formula has entered the vernacular. If you don't know what that means, it's almost everyone you know knows about H2O and what H2O is. And it reminded me of this stupid little joke about two gentlemen who enter a bar. The first one asks the bartender for H2O. And the bartender asks the second individual, I'll have H2O too. And the second individual dies. If you don't know or catch the joke, then you should go back to your first year chemistry. But that's just a stupid little joke. There's roughly 1.37 times 10 to the power 9 gigatons of water on the planet. I'm not going to go into all the details about how much fresh water, how much salt water, how much ice, what's in glaciers or not. What is important to remember is that this amount is finite. And what finite means is that the same amount of water that was there when the planet was in its creation stage is still here today. It's just captured in different places in our bodies, in the forest and trees, in fresh water, in the salt water. But it's a finite resource, and that's a very, very important point. Water is also the great architect of our natural landscape. And if you've been fortunate enough to come to Cape Town or seen pictures of Table Mountain, one of the major forces of erosion of the mountain is water. As it expands and it contracts, it cracks rock, and it creates a sand and soil. It's really, really important. But other than that, water is also very weird in a chemical sense. And this is very important. In fact, it's one of the most unusual molecules on Earth. It boils at temperatures that it shouldn't. It expands when it floats, when it's in its solid state, and its surface tension is higher than it should be. Now, we'll get to all of that a little bit later, but just keep in mind that water is a very weird little molecule. Now, strange but true. Now, here I have a glass of water. Now, this glass of water, as you can see, it's a liquid, clearly. It's colorless. It's odorless if you're lucky enough to stay in a country where the water from the tap is odorless, but it shouldn't be a liquid at all. It should be a gas because it's not following any of the laws that liquids usually do. Now, we'll get to that also a little bit later, but there was this little gentleman called Erasto Mpemba, all the way from Tanzania, who said, well, he did this little experiment in school, and he came up with the idea that hot ice cream freezes quicker than cold ice cream. Now, his classroom teacher laughed at him, but he wasn't the only one to say this. In fact, Aristotle, Francis Bacon, and René Descartes all came to exactly the same conclusion. Now, we'll get to this a bit later, but why is water a liquid? Why? I mean, why is it different from any type of gas? It should be, if we think about it chemically, in a vaporous form with no water at all visible on Earth. And if we compare it to different molecules like hydrogen sulfide, H2S, as an example, the gas is twice the molecular weight of water, and yet it's in a gaseous form. Now, other similar sized molecules such as ammonia and hydrogen chloride are also gases. Now, why is water in liquid form and not a gas, if, as its counterparts, it's not in a gaseous form? Now, this is the answer is really interesting. Water is sticky. If you take the water and you put your finger in and you wait for the drop, you can see that the drop of water that falls takes a while to leave your finger. Why is that? Because water is, in essence, sticky. Not like toffee, it's a bit different. There's hydrogen bonds that form between the hydrogen molecule and the oxygen molecule. You all know, or now I'm talking to the students now, that water is a molecule made out of an oxygen molecule and two hydrogen molecules, which is very light molecules. They were created, some of the very first gases created in Big Bang billions of years ago, together with lithium and helium and all of those. But each water molecule is able to form almost 4 of these hydrogen bonds. That's what makes it sticky. That's what makes it one of the most cohesive and unique liquids on Earth. So that's really, really interesting. It's all about just a simple hydrogen bond. Now, for the students, you are studying what Dr. Masabedi called global change biology, and the importance of the anthropogenic influence. Now, for those of you who don't know what anthropogenic is, I hope the students do. You're supposed to do. And as we heard in a previous lecture of Unlocking Nature, anthropogenic is not yet an epoch, but people are fighting about it. But it's all about our influence as a species on the planet. Now, why is all of this important? Why is it important to remember that water is a chemical and that it forms bonds and that it's sticky and that it's unique and all of those things? Because water is indispensable for Earth resilience and sustainable development. Why? The functions of water dictate the capacity of social economic changes to sudden changes in the environment. And what do we mean by that? What are the functions of water? Now, water can be seen as the bloodstream of the biosphere. Everything needs it. Life equals water. That's what we know. And there are 3 green functions of water and 4 blue functions in water. And if we go into that, we can have a whole new lecture on all the ecosystem services that water provide as a function. Now, the sudden changes in the environment that are brought about by human interference or the anthropogenic effect include climate change, dam construction, land use, the removal of topsoil, and a myriad of other things that we can come up with that causes sudden changes in the environment that directly links to the functions or the ecosystem services that water provides. So it's very clear that we need water, and in many cases, the changes in core water function has pushed so far that has pushed some of the ecological systems beyond the tipping point. Now we're talking about desertification, savannification, and all of these very important things. It's indeed another lecture all on its own. Beyond this tipping point, and we as scientists and people who study science know this. And what do we need and what are we going to do about it? We know what we need to do. We have the information, but we need to go back to basics and understand what is needed and make science accessible to the general public. So we can have a myriad of other lectures about how important all of these points are: the resistance of water, water functions, the water cycle, and all of that. But what really proves a point in the usefulness of water is what Richard Dawkins calls the magic of reality, to make the public understand the usefulness of water. So we go back to basics, we go to the public and tell them, listen, guys, you know that water is important, but why is it important? We need to change the narrative that we use as scientists to explain the problems that the public are facing. So this is a question, or actually not a question. It's something that I'm going to state to the students. That's really important. You are fourth years, if I'm not mistaken. It's really important that you understand that everything that you learn, you need to be able to explain to someone else out there. And if you can't explain the intricacies of science and why water is important and why there is almost 700 million and trillion tons of water in the Pacific Ocean that we can't use, why is that? That's what makes water useful, is that we can use it as a story, as a narrative, to create more understanding and a better bond between general science, or science as a specific subject, and the general public. Ladies and gentlemen, now I missed the slide. Goodness, wait. Thank you very much. And for the students, let's hope that you never look as confused as I am doing here with my net, trying to catch fish in the De Monde estuary, or for many years ago. I can't remember. I think I was 21 at the time. But that's it, ladies and gentlemen. Thank you very much. And I'm open for questions and answers.
So everybody, you are welcome to ask questions now. You can use the reaction tools at the bottom of the screen to draw our attention to you. The Botswana students, you can either, if we can communicate, you can switch off your mic and talk to us, or switch on your mic. We can unmute you, and you can also write a question in the chat if you would like to do that.
Yes. And any questions are welcome.
Questions or comments?
Or comments. Comments are just as important.
Yeah, I have a question. And if you have any question, you can ask. What is your, given the projected climate change, especially precipitation patterns in Southern Africa, what would you say, what would be your comment about water availability, especially to, different livelihood practices like agric? And what would you say about, what would be your comment about the anticipated changes in climate and water?
That's a very important question, Doctor, and thank you very much. And if you look at the last couple of years, and I'm going to start with Cape Town, where we went through a serious drought, and which we call day zero, as some of you might know, where we almost ran out of water, and just in time it started raining again. It's very important to remember that I think that the current climate models that we have don't really fit at all. If you look at the interior of South Africa at the moment, they are receiving immense amounts of rain. It's flooding in KwaZulu-Natal, in the interior parts of the country, the Northern Cape, the Free State. It's raining so much that the farmers can't actually harvest the crops, which is a really big problem because the crops are rotting on the fields. So as it stands, I wonder, and I think, Prof, if you get to listen to Prof Peter's talk about climate change, I don't think that at this particular moment in time, the climate models can tell us what the future holds. But what we do know is that these extreme weather patterns are definitely going to increase, where you find places that didn't have a lot of rainfall during the yearly rainfall will have a lot of rainfall, and places that don't will have, and vice versa. So I definitely think the weather, the climate charts and predictions as we have them are just not suitable anymore. I hope that answers your question.
The question I got from them and one of the students is that we had elephant deaths in one of the drought years. Should we anticipate more deaths, you know, with reduction in rainfall? I think that is the question, if I got it well. That there was some elephant deaths, and what can we expect more deaths with the reduction in water on the landscape here in Botswana?
It's a very, very good question, and I think it has everything to do with two things: climate change and the reduction in rainfall, but also in the natural movement of elephants. The migration cycles of elephants, because as we know, I mean, creatures migrate towards water, and if there is no water, they'll migrate to places where there aren't any water. And if we fence off the greater parts of these migratory routes, then definitely there will be more, not only elephant deaths, but other greater mammal species deaths as well. So definitely, I mean, if it doesn't rain and there's no water, and they can't migrate to places where there is water, then definitely those numbers will go up in the future. I hope that answers the question partly. If someone else in the audience has something to add to that, please do. It would be wonderful to hear your opinion. Dr. Richard? Seems like there's some action there. We'll get to them now. Thank you everyone for listening, and thank you for the thank yous in the chat.
I was asking, well, more of I don't understand. You mentioned about roots, and I wanted to know how the rainfall there plays a part.
In migration routes.
Yes, because there were roots that they talked about.
The elephant migration
yes.
routes. So you want to understand how rainfall, changes in rainfall patterns will affect migration routes.
Is it that those migration routes, if there's more or if there's less rainfall, then they're going to lack water for the elephant?
Okay. So the question is, how exactly do we anticipate changes in rainfall to affect migration routes? And I just want to add to what she's saying. You know, if we understand how it will affect migration routes of elephants, for example, we can have you know, mitigation strategies in place that, you know, help to reduce human wildlife conflict. So I just rephrased your question and added a bit of flesh to what she was asking.
Yes, definitely. No, I completely agree with you, and that's what it boils down to. If we understand, and this is critical, if we understand the changes in climatic conditions over a longer period of time, I'm not a climatologist, but at this particular point in time, I think it's really difficult for climatologists to tell us what exactly is going to happen. We know it's called climate change and not global warming anymore, because it's getting warm in some places and colder in other places and wetter here and drier there. But it's very important to remember that when animals need water, they will migrate or they will move to a new water source. They will find water. But if we fence off particular areas, like in Botswana with the cattle fence, or Chobe National Park, or even in South Africa, the Kruger National Park, and these animals can't migrate anymore or can't go looking for water, then of course they're going to die of thirst. Titus, thank you. I'm just seeing your comment here that the deaths of the elephants, and you're correct. I remember this reading it was due to cyanobacteria from a worsened algal bloom. And the climate change is still a key factor to bioterrorism, and without ecosystem-based adaptations, then we are going to experience more. And I completely agree with that. And that was a particular case, Titus, where the elephant died of particular bacterium. But I think, if I'm not mistaken, if we go to just a global or a region-wide view, if there is no water to drink and the elephants can't migrate, then of course they'll die of thirst. But a very valid point, Titus, very valid point. I hope I answered your question. So if they can't migrate to other places where there is water, then they'll die. It's just like us. If we don't have access to water and we can't get access to water, then eventually you will die of thirst as well.
Thanks. Yeah, that's well answered. But there's just one more question. I'll give the student to ask.
Perfect. Thank you.
Thank you for taking my question.
Thank you for asking.
Thank you for taking my question. We all know that more of something, even though that thing is important, more of something actually means it can be poisonous. I heard you talking about flooding in South Africa, and you have been mentioning migration of animals from places where there's no rainfall towards where there's water sources. But how do flooding events change that narrative to cause animals from places where there's flooding towards to where there's no water sources? If that's understandable.
Okay, lovely. So I think the important fact to remember here is that in Southern Africa, most of the animals, as it were, are kept in national parks, reserves that are fenced off, very particular areas. And if you have floods like you have in KwaZulu-Natal at the moment, and there was a drought, say in Izimvelo National Park or Isimangaliso National Park, then that solves the problem. Then, okay, some animals might die because of the flooding, rivers coming down, mud storms, stuff like that, but then it solves the problem. But then there is enough water for the elephant or for the animals to consume. But it's still a problem that if there isn't, and it rains just next to the park, the animals can't do anything because they can't migrate to the water. And that's a big issue here, is fences. That we as humans love building fences, and these fences create, take away the opportunity for these animals to migrate as they usually would to places where there is water from places where there is no water. I hope that answered your question. Any other questions from the class? Thank you very much for listening. Please take my take-home message to take it home. One more question. That's perfect. That's absolutely perfect.
Thank you very much for the short and interesting lecture.
Thank you very much for listening.
I heard you saying that you worked with Professor Van As, and my question is, what do you think could be the effects of the warming climate on fish and parasites, the interaction between fish and parasites, and what could be the implications for fish health and human nutrition?
So if you think about general biology and general ecosystem health, when there is a change in a drastic change in water temperature, any individual, this is evolution 101, will either adapt to the changes or then die because of the changes. And if they are, let's say the water temperature rises a lot and there are stresses on the fish, then you would think that if the fish are stressed, the parasite load will increase. or the fish might just die off because they can't breed anymore, or stuff like that. It's a general biology. So yes, if there is an increase or a decrease in water temperature, there will be stress on the fish, and I would imagine that the parasite load would increase. Professor Van As, I'm not sure if you are listening. If you want to contribute and prove me entirely and utterly wrong, that would be lovely. But yes.
Well, Ruaan, and good afternoon to the rest of the best students. You were spot on, Ruaan, and just the student to ask the question, you must keep in mind, fish have been around since the Devonian time. We're talking 400 million years ago. They're still around with us. There's going to be climate changes, and it's going to happen. Us as humans aren't going to be around, but the fish will be. And then the one thing that Ruaan says that we can just stress about, we actually hate the word parasites, because a lot of these organisms we found associated with the fish aren't parasites. They're just living on it. And sorry, students, you were all parasites for 9 months when you were in your mom. So one also have to look differently at the definition of parasites. And in the world of parasitism, there's a lot of symbiotic associations that is taking place. So just as the fish will adapt, so will the parasites with them as well. But well answered, Ruaan.
Yes, thank you, Professor Van As. It's an arms race, if you think about it. If you think about it in evolutionary terms, as one changes, as one adapts, the other will adapt. But it's also interesting about water, just so that the students remember this, and that's why fish are such an incredibly hardy species, is that water, as when it solidifies, it floats on itself, and that is strange for a liquid. And throughout all the ice ages, throughout all the epochs in life, even when there was a thick covering of ice, the fish could still survive in the water below without any massive changes or whatnot. But thank you very much, Professor Van As, and thank you for the student for the question.
Okay, you were talking about water flowing, especially in colder temperatures. I was wondering if there's any way that in warmer temperatures, then can water also have like, is it possible for the water, especially if you say water, if it freezes at the top, but you find that under it's not freezed, is it possible that in warm temperatures something like that might happen? So as to, because we are talking about fish and stuff, so if it's in warm climates, can't the water also have, under there, can't it be cool or something?
Yes.
You talked about the properties of water, the hydrogen bonds, and that when it freezes, it floats. And that is important for lakes and aquatic systems, because it then shields, it insulates the life, the aquatic life. But what she's asking is, do you think when it's hot, the colder water in the deeper, in the lower depths, how do I put it, in the deeper parts of lakes and and other aquatic systems can play a protective role, because then the temperature there may not fluctuate much? I think that's your question. So she's asking about the opposite, that water seems to protect life during cold weather. And she's asking whether it may protect life in hot weather by virtue of being cold at the deeper parts of lakes.
Wonderful. That all depends on the species that we are talking about. and the biology of that species. If you think of the deeper layers of lakes and of the ocean, you get different types of species that are adapted to much less sunlight, colder water conditions, and so forth and so forth. So that really all depends on the species that we're talking about. In warmer temperatures, in warmer waters, we know if the temperature rises, especially in the oceans, you get the corals dying off, and even when the temperature goes down, the corals start dying. But that really all depends on the species that we find within that particular body of water. It might not. It all depends if that species can adapt to that quick a change. And it's also important to remember that time plays a very important role in all of this. If there's a sudden change in the climatic conditions, in the water temperature, then most of the species might not be able to adapt to that sudden change. And if they do, they survive. And yet again, that's evolution 101. Cool. Wonderful. Thank you. I hope that makes sense.
Ruaan, apart from climate change, what other threats are there to freshwater systems? If you could pinpoint.
Oh Lord, so many. I think Dr. Richard is
where can we make a difference?
But agriculture, land use, planning of cities, spatial planning, where people move to. I mean, deforestation. So many things play a part in how the water cycle works, and there really is water management systems. If you take a place like Lake Victoria that's shared between 4 or 5 different countries, legislation. There's so many things that play a role, but definitely land use practices, I think, is one of the main reasons why our freshwater systems are under such incredible pressures. What goes into the water? What flushes into the water? What do we put into the water? That's one of the key, the main issues that we can do another talk about. I'm absolutely sure. Yes, definitely that. Yeah. Thank you, Ruaan.
And thank you to everybody that was here. Thank you to Botswana International University of Science and Technology. It was lovely to spend time with you this afternoon. It would be great to do that again in the future. And Dr. Mazaberi, thank you for introducing us to your students. If that's all, no other questions, then we are going to say goodbye. Thank you, Ruaan, once again. And we will see you in the share screen session.